Alright, we have an OpenID Connect compliant resource server now, within our Elastic Query service. I want to extend it more by adding a custom permission evaluator. First, we will add Spring Boot Starter Data GPA and PostgreSQL dependencies. I will use 42.16 version for PostgreSQL here, which comes with Spring Boot. And also note that my local PostgreSQL is running in version 12.3. First of all, I will add two files, init schema SQL and init data SQL. Let's put them into resources to update the local Postgres database. At this point, you should have a local Postgres running as it was required in Keycloak section. So if you still don't have it, please download and install Postgres database locally. In init schema SQL, we will create three tables: users, documents, and user permissions. Users will refer to users defined in Keycloak admin console. Documents are the documents on Elasticsearch. And finally, user permissions are the permissions per document per user. We defined a permission type column to specify the types of permissions in the user permissions table. Then in the init data SQL, let's first create extension UUID OSSP to be able to use UUID generator in Postgres, and then insert users first by inserting ID username first name and last name. All we can copy from Keycloak admin console, including ID, as there is an UUID definition there for users. Then for documents, I will insert three records for demo purposes, and set random UIDs for ID on PostgreSQL, and use the documents with ID 1, 2, 3, which were the documents we added in Elastic Query section. To match all documents to users, we could create an admin panel and do the matching by using that panel, or can run some scripts to match them. But for now, I will add these three documents for simplicity and to show the usage of permissions in Spring Security. Now for user permissions, I will use UID generator from Postgres to create a random ID. And for user ID and document ID, use the correct IDs from users and documents tables. For permission type, I will only use reads. As this is a query service, we will only use read permission. As you can see, the app user can only read object with ID 1, while the user admin can read all three documents. For a super user, I will add a single permission, but as we will see shortly, super user will be able to see all the documents, regardless of the permissions defined. Now please go to the query service configuration file and update it with the required database properties. First add Spring JPA prefix and set OpenInView to false, which is by default true, which causes the persistent context to stay open, which is not good for performance. And then set showSQL to true, database platform to PostgreSQL 9 dialect, and for Hibernate dialect also set the same PostgreSQL 9 dialect. And for Spring Data Source, we set Postgres database connection URL. Use public schema and also use binary transfer true for better performance, and enable the batch inserts at database side, which will run all the insert statements sent to Postgres in batches, as long as they are in the same transaction. We also set username and password. For password, I will use encrypted version by using Java cryptography extension and Spring command line utility as we did previously. Then set driver class name as PostgreSQL driver. And then set platform and the schema and the data files that we defined to create schemas and to insert the data. You can use class.bat colon and then the name of the files for the schema and the data SQL files. And we set the initialization mode to always, which will run the SQL files each time application starts, which is okay for the demo purposes. Before continue, let's commit and push config server changes as we always do. Then we can create a data access package, and then add entity and repository subpackages. I will add user permission entity with JavaX persistence entity annotation as well as Lombok data annotation, and then add UID ID, string username, string document ID, and string permission type properties, all with not null validation annotation. This entity represents a database table, and all these properties represents database columns. We will use this entity in the repository. Then let's create the user permissions repository interface in repository package, and then extends JPA repository with generic types, user permissions, and UUID. As you can see, we refer to user permission entity we just created. Then create a single method here, find permissions by username with parameter username and with the param annotation, and return an optional list of user permissions. We will use a native query with query annotation here, and write a SQL query to join users, documents, and user permissions. And then return permissions ID and username of user along with the document ID and the permission type. Here we use param annotation to pass the username param, which defined in query using a colon. Then I will create a Spring component, user permissions to user detail transformer, under transformer package, and convert a list of user permissions into a Twitter query user object using method getUserDetails. At this point, we need to update Twitter query user. First, create a permission type enum with possible permissions like read, write, admin. And here use a string type property and set it on constructor. Then let's add a private map with key string and value permission type to do Twitter query user and name it as permissions. And since we have Lombok annotation, we do not need to add any get method here explicitly. And then return to transformer and set username and the permissions using boiler pattern. We will convert the list of user permissions into a map of document ID and permission type, and then set it into the permissions of Twitter query user object. Alright, I will now add a service in business package called query user service to return an optional list of user permissions with method findAllPermissions by username, which takes a parameter username. Then let's implement this interface with Twitter query user service class and annotate with the service annotation and inject the user permission repository we just created. We can then simply call the repository's findPermissions by username method to return list of permissions wrapped in an optional object. Let's also add a log variable here and add some info logging. Great, we can now update the Twitter query user detail service class and inject the Twitter query user service and user permissions to user detail transformer objects. And in the load by username method, call user services findAllPermissions by username method. And then map it to user details using the transformers getUserDetails method. And if no user found in the database, throw away username not found exception with a message no user found with name. Finally, I will add a custom permission evaluator component that implements permission evaluator. Let's name this class as query service permission evaluator. And then override hasPermission method with authentication, target object, and permission object. And also the method with the parameters authentication, target ID, target type, and permission. In the first hasPermission method, if the target domain object is a request object, then we need to handle it for pre-authorize. So let's create a method for that and parse the target domain to request module and get ID to pass the pre-authorize method. And if the target object is a response entity, that means we are returning from controller. First, let's also check if target domain is null, because in that case we should still return true, as that means no documents found. Then I will extract the body and then create a post-authorize method to pass authentication, response body, and permission. Let's now implement these pre-authorize and post-authorize methods. In the pre-authorize method, I will get the Twitter query user object using the authentication getPrinciple method. And then get the user permissions and search for the document ID for the requested object in the permission map. If we cannot find the document ID in user permission list, return false, or if permission types do not match, also return false. Otherwise, return true. Next, create a method for this check so that we can use it from post-authorize method too. In the post-authorize method, we iterate all response model objects and check if user has permission to the returned object to do the defined permission, which is always read in our case, as this is a query service. We return false even for a missing permission for a single object inside all the return list. So we expect that user has permission to all documents he or she queried. Alright, let's check this response body also with objects require non-null as it cannot be null. For the hasPermission method that takes ID, we can return false if ID is null, and then call the pre-authorize method with authentication object, ID and permission in this hasPermission method. Note that for the version v2 model, This logic needs to be updated. For now, we will skip that and only work with V1 models. Finally, I will add a check at the beginning of hasPermission method and return true for a user that has superuser role. This is for the sake of this demo, as we still want to query all the data with a user, and do not want to match all the documents for now. Let's create a constant for the superuser role. We could get granted authorities from authentication objects that we get as a parameter here, and iterate over it and check if a user has role superuser. But instead, I will inject HTTP servlet request, which is actually an instance of security context holder aware request wrapper, and use isUserInRole method in this class, which will do the same job for us. It is like calling the hasRole method inside pre-authorized annotation. Let's create a method isSuperUser here and check if user has this role and call this method at the beginning of hasPermission methods. So as you see here, you can implement a custom permission strategy according to your application requirements. Alright, we are now ready to update controller with permissions methods. Let's add hasPermission check for request and return objects with the permission type read. I will add post-authorized hasPermission with return object and with the permission read to do getAllDocuments. Then update getDocumentById methods and add pre-authorized annotation and call the hasPermission method with ID, target type and permission and check the permissions. Note the syntax here. For return object we use return object directly, but for ID we use expression. And for getDocByText method, let's first add a hasRole for the superuser and also add a post-authorized annotation with the method hasPermission, and for return object let's check read permission. I will now run the Elastic cluster and config server and then run the query service. Then obtain an access token from the keycloak as we did in the previous section using grant type passwords for user app user first. Finally, let's call the query service on Postman. I will first call getAllDocs. It should fail as we didn't add all the documents to the user permission. So let's also try getDocById. App user can only fetch document with ID 1 because if you remember we only added document 1 to the app user. And for the other documents 2 and 3, it should fail. Let's also try getDocumentByText. We have documents ID 1 and with text test multiword, ID 2 with text multiword, and with ID 3 text with only word. If you query with test, it will only return a document with ID 1, so app user can see it as you can see. But with query text multi or with word, it will return more than one document, so we will get an access denied, as app user can only see the document with ID 1. Let's now get a token for app admin user and call getAllDocs methods. It will still fail, but getDocumentById should return data for ID 1, 2, 3, as we gave permission to these documents to the app admin user. Then let's check getDocumentByText for the app admin user. It should fail because app admin user has the role app admin role, and in the getDocumentByText method we didn't allow for this role. Finally, a token obtained for a superuser should be able to query all the data, as we return true in hasPermission for a superuser role. So getAllDocuments will return all the data. We can also see all the documents with the getDocumentById. And finally, getDocumentByText even return data if you query with Kafka or Java as the text, which will return all the data that matches these words. As you see, we have now more granular checks in object level using hasPermission methods, as well as in role and scope levels using hasRole and hasAuthority methods. Alright, we finished implementing the resource server. Now it's time to add a OAuth and OpenID Connect compliant web client. Let's do that in the next section. Alright, good job so far. I will see you in the next section.